Hello, I'm Adam Keller, and I'm a developer advocate on the container service team here at AWS. Today we're going to dive into ECS Capacity Providers and look at how we can shift the focus from operational heavy lifting to application first. And so with that said, let's get right into it. On the agenda, we're going to look at ECS launch types and understand the different ways that we can launch containers, otherwise known as tasks, in ECS into our clusters. Next, we're going to talk about the scaling considerations. And, when we think about running a container orchestrator, there's quite a few areas of scaling that we have to think about. And we're going to see how the capacity providers can solve some of those pain points as we progress through the presentation. Then we'll dive into capacity providers. We'll do an overview, and then we're going to talk through some different scenarios in which you can use capacity providers to help enable your teams to, as I mentioned earlier, focus less on the heavy lifting and more on the application first. And lastly, we will finish off with a demo where we will actually see cluster autoscaling in real time as we scale an application out, and then we watch as the cluster EC2 infrastructure scales to meet the demand. So let's talk about the launch types in ECS. And when we talk launch types, there's two ways to launch containers on ECS. One, on the left, you can see without Fargate. So this is with EC2. And so when we say EC2, this is where you have to focus as the operator managing the environment. You have to think about instance capacity, ensuring that it's available, ensuring that those EC2 instances are patched, and that they're ready to serve containers in your cluster. And there's much more that goes into that. It's not just patching, but it's doing rolling restarts on your instances, keeping them fresh. One thing that's very common when we talk containers is immutable infrastructure. So it's building your infrastructure in a way where it can come up and down, be terminated, a new instance can come up, and it's ready to go and ready to serve those containers. And then to the right, we see with Fargate. Now, if you're not familiar with Fargate, Fargate's essentially a way to deploy your containers in a serverless type fashion, meaning you don't have to manage the underlying EC2 infrastructure that your containers run on. So all you focus on is deploying your task or your service, and then thinking about how you want to scale that task or service to meet the demand of your customers or of your users. So now that we have an understanding of how you can deploy containers to an ECS cluster, let's talk about the different scaling considerations that have to take place. So when you have an ECS cluster, one thing to note is an ECS cluster can be mixed between Fargate and EC2 as your launch type. So when we talk AWS Fargate, your focus is scaling the application. I've deployed my service, it's running. Now I want to make sure that as the demand increases, that I am able to scale that service based on whatever metrics I've deemed necessary for that service to scale, and I want that service to scale out and in as needed. That's all you think about with Fargate, because again, the underlying EC2 infrastructure is fully managed and abstracted from you as the one deploying the service. And then there's the other option of deploying, which is, as we mentioned, Amazon EC2 backed ECS tasks. So with EC2, I have to think about scaling in two places. One is the service, as I mentioned before with Fargate. So I have to think about scaling that service out and in as demand ebbs and flows. But as demand increases and I need to scale out my tasks, I also need to make sure that I have enough infrastructure or EC2 instances for those tasks to get scheduled onto. Now, there's a couple ways you can do this. One, which is, a way that you spend more money, but it probably less ideal, where you have just excess capacity to handle the scaling. But frankly, if you're doing that, you're not really taking advantage of the cloud, of AWS, and all the features that are out there to help you save the money and not spend the money on idle capacity. So with that is the other option, which is where you have to think about auto-scaling the instances on your own and ensuring that as your tasks scale out, you understand and have the logic figured out to scale your EC2 instances out to make sure that those tasks get served. And of course, once you're done and you've completely scaled back in, you have to also think about how do you scale those EC2 instances in so you're not paying for excess capacity. So let's talk about capacity providers. A capacity provider is used in association with a cluster to determine the infrastructure that a task runs on. So when we talk about ECS Fargate, there's two ways to deploy Fargate tasks to a capacity provider. First of all, the Fargate and Fargate Spot capacity providers are the way to do it. And these are predetermined, pre-made, ready to go out of the box capacity providers. You can't edit them, you can't delete them. These are just ready to go. And so you can schedule your Fargate tasks to span across one, like a Fargate capacity provider, or two, a Fargate and Fargate Spot. We'll look at that in real time. We'll actually show an example of that in just a moment. And then there's EC2. So for the Amazon ECS on EC2 users, a capacity provider consists of a name, an autoscaling group, and the settings for managed scaling and managed termination protection. We will go over that in our demo live, and we'll actually show you how that works in real time, and we're going to create a capacity provider on the fly and do that live. So now that we understand the different ways you can deploy to an ECS cluster, the different types of capacity provider options that are out there, let's actually walk through what that looks like from a cluster level. So we have our ECS cluster, and then we need an autoscaling group. And when we're talking autoscaling group, again, we're not talking Fargate, we're not talking Fargate Spot, because those are already created and ready to go. So this is looking for EC2-backed ECS tasks. So we have our ECS cluster, we have our autoscaling group. That autoscaling group is going to schedule instances to ensure that they can serve the tasks. And by the way, which I'll show you in the next slide, but it's hard for me to not just talk about this, is you can actually have an autoscaling group that sits at 0 instances if there's no tasks running in that capacity provider. So we'll talk about that in just a moment. And then wrapped around your autoscaling group is where your capacity provider comes in. So this is a new resource type in ECS. And as we've talked about, what it does is it abstracts the capacity management out from your hands and into the ECS capacity provider's hands. So now, when we talk application first mindset, you focus on scaling your applications, deploying your applications, and you focus less on managing the infrastructure and scaling the infrastructure to meet the demand of your tasks and services. You can have anywhere between 0 and 10 capacity providers assigned to a cluster, and ultimately your tasks and services will be using those capacity providers. So let's actually walk through an example here. So we create a cluster. This is a one-time event. We create our autoscaling group, and then we create our capacity provider, which points to that autoscaling group. Now in this example, I have an empty EC2 autoscaling group. So, and what we'll show in the demo later is I'm able to create these resources without actually creating and deploying EC2 instances yet. And then once I have this all running and ready to go, so it's one-time creation for the cluster, the capacity provider, the autoscaling group, I then run my ECS tasks. And when I run those tasks, I assign them to this capacity provider. And the capacity provider, behind the scenes, is going to recognize that there's an excess of tasks that don't have capacity to run. It will start up the EC2 instances, and then once those instances come up, join the ECS cluster, it will actually place those tasks and schedule them onto those EC2 instances. So let's look at another example, and let's start talking about capacity provider strategies. So when we talk strategy, capacity provider strategies, this is essentially a way to control how tasks are assigned to capacity providers. So in this example, we'll have two capacity providers, and the strategy between the two is that I want a base of 3 for capacity provider 1 and a weight of 1. And when we talk about a base, that's essentially the minimum amount of tasks that I want deployed to that capacity provider before we schedule these tasks to run on the other capacity providers or to go on our weighted capacity provider strategy. So in this instance, we have 5 total tasks that we need to schedule. 3 of them we want to ensure that they meet the base and that they're deployed to capacity provider 1. And then we have the weights of 1 and 1 between the two capacity providers. And what that means is once we've met our base, then for every 1 container or task deployed after, it's going to be split between capacity provider 1 and 2. And as you can see here, that's exactly what happened. So taking that same strategy and that same process, what if we apply that to Fargate and Fargate Spot? Previous to this, capacity providers and the Fargate and Fargate Spot capacity providers, this was challenging to figure out how to do this on your own. And if you wanted to take advantage of the cost savings of Fargate Spot, oftentimes you had to make a decision of deploying to one or the other. But now with capacity providers, you don't have to make the decision of one or the other. You can take advantage of both. So let's look at a strategy of a base of 1 for Fargate with a weight of 1. And then for Fargate Spot, I want a weight of 4. So for everybody listening right now, watching, if you do the math, that means that we want 6 total tasks. And with those total tasks, we want to ensure that 1 is deployed at a minimum. So we have our 1 task running on Fargate. And then after we deploy that 1 task, we expect for every 1 task deployed to Fargate, 4 tasks will get deployed to Fargate Spot. So as we can see, we've met our base of 1. Now we want to schedule the next of the total 6 tasks to be split between the two capacity providers. So this is a great way to take advantage of the cost savings you get with Fargate Spot, but not limit yourself and to only using one over the other. Okay, so now going back to EC2 and autoscale groups, let's again go back to splitting the scale out strategy. So again, going back to a very similar strategy that we've had before, where we have a base of 3 for capacity provider 1 and a weight of 1 between the two capacity providers. We have our current scenario, okay, without scaling, just our base setup was 5 total tasks. And you can see those 5 tasks are split between the two providers according to our strategy. We have the 3 base, which you see in capacity provider 1. We then have our weight of 1 for capacity provider 1, so we should have 4 total there. And then capacity provider 2 has a weight of 1, and you can see we have the 1 task running there. As it scales out, it again follows the weights, and what you'll see is that gets split between the two capacity providers. So now we have 7 total tasks, 5 running on capacity provider 1 and 2 running on capacity provider 2. So just another way that we can split that scale out to work as we see the best fit for our environment, our cluster, or not even your cluster, it can be for your specific set of tasks or services that you want to run. Another strategy that you can take advantage of is having that availability zone balance with capacity providers. So we can have 3 EC2 autoscaling groups, and it's important to just note that a good practice, well-architected practice, is not to deploy to one availability zone, but if you want a highly available fault-tolerant application, to deploy across multiple availability zones. So in this example, we have 3 autoscaling groups across 3 availability zones. Each of those Autoscaling groups has been assigned to a capacity provider, and our strategy is to set a weight of 1 for each capacity provider in each availability zone. So what happens here? Well, what we're ensuring is we're going to get an equal number of tasks deployed to all 3 availability zones because we're splitting them across all 3 capacity providers. And as we have to scale out, our instances will scale out to meet the demand of the tasks. And this is done through the autoscaling groups. And another really cool thing to talk about is spot instances. So it's possible to take spot, and if you wanted to split across, have one capacity provider as your on demand and 2 capacity providers as spot, you could do that as well. So there's quite a few different ways that you can diversify your tasks with using capacity providers, whether that's using EC2 and splitting, and when I say spot, this is for EC2 instances, but you can, of course, as I showed earlier, schedule across Fargate and Fargate spot. But this is a way to schedule tasks across EC2 and EC2 spot instances. So quite a few different ways to do this and to achieve your goal of running your tasks how you see fit based on your organization's needs, your cluster needs, and your service needs. Okay, so now it's time for the demo. So we're going to demo 2 things today. One, we're going to demo an EC2 backed ECS task, and we're going to point that task, that service, to a capacity provider that's pointing to an autoscale group. So we will create the capacity provider in the console, and then we're going to update the service to point to that capacity provider, and then we're going to scale that service out, and we're going to see that there's no EC2 instances in the autoscaling group when we start, but then the capacity provider will initiate the scaling event because we'll have tasks that are requiring capacity that doesn't exist, and then it will scale to meet the demand. And 2, we're going to deploy a service that will be split across Fargate and Fargate spot capacity providers. So let's get right into it and let's get started. So here's my ECS cluster. And in my ECS cluster, I have 2 services that are active and running. And when I say running, they're actually running 0 tasks, so they're not running anything really. So we're going to start with our EC2 backed ECS service. I'm sorry, I may have called these tasks or services. So we're going to go to capacity providers in the console. And again, anything I'm doing in the console can be done via CloudFormation, via the command line. But it's I think for the sake of a demo, it's nice to see it visually through the UX. So we're going to create a new capacity provider. I'm going to call this capacity provider container conf demo. And then we're going to point it to a autoscaling group. I created this autoscaling group prior to the demo. So it's, basically I had the cake in the oven. It's ready to go. I just took it out. So now we're going to go to manage scaling. I'm going to enable it. And again, as a reminder, we talked about this earlier, but manage scaling is when I enable it, it's enabling cluster autoscaling to be managed on the capacity provider. So the capacity provider is handling the EC2 instance autoscaling out and in on my behalf. So I'm going to enable that, and we're going to set the target capacity to 100%, meaning we want to ensure that we are as dense as possible with our scheduling of our tasks to ensure that we don't have excess capacity. And again, this is going to be a best effort based off of the instance we chose for our autoscaling group, etc. But our best effort is going to be as close to 100% cluster utilization of those EC2 instances as possible. And lastly, we're going to enable managed termination protection. This is to ensure that as instances scale in, that if there's any tasks that are running on those instances, those particular instances won't be terminated. And the exception to that rule is for any daemon services. So a daemon service is when you essentially say, I want to ensure that one service is running on all EC2 instances that come up and that are added into the cluster, those don't count. If there's a daemon running and that's it, that'll get terminated. So let's create the capacity provider. And as you can see here, this is actually a good example here. I got an error that's saying in order to enable managed termination protection on the capacity provider, I have to have that also enabled on the Autoscaling group. So let's go and do that really quick. Sometimes I think, you know, when you're given lemons, you make lemonade. This is an example of an error in the demo, but I like it. It's something that we can learn from and modify. So I'm going to go to the Autoscaling group here, and I'm going to click Edit, and I'm going to enable instance protection, protect from scale in. So I've enabled that on my Autoscaling group. This is one of the requirements. Now we're going to go back to the capacity provider, and we're going to create. And what we can see is our capacity provider has been created. So let's take a look at it in the cluster. So as you can see, I have a few capacity providers set up on my cluster already. And for the sake of the demo today, we're going to be looking at the top three. So Fargate Spot, I enabled these prior to the demo as well. And remember, Fargate and Fargate Spot capacity providers are created by are there by default. I can't delete them or modify those capacity providers. They're just available for me to enable on the cluster and to use. So we also have the container conf demo capacity provider here, which is the one we're going to use. A couple things I want to point out. So one, we have managed scaling and managed instance termination enabled. You can see here the current size of the Autoscaling group is 0. The desired size is 0. Minimum size is 0. The one thing I do need to also modify is the max size, and I need to change that to 10, or whatever I want. So I'm just going to change it to 10 for fun. And now when we go back, so now we can see our minimum size of our Autoscaling group is 0, meaning we can scale down to 0 if we don't have any tasks that need EC2 instances to run. And we can scale up to 10, meaning if there's a scale out event that's so great that it goes up to 10, I'm okay with that, but I won't allow it to go past 10. So this is just a way to have some safeguards in place to ensure that if a scaling event goes beyond the expectations or crazier than you expect, you're not dealing with thousands of EC2 instances running and paying for that and having to deal with that. So it's just a good safeguard to have in place. Okay, so now we're going to go to our service, and we're going to start with the EC2 service. Okay, we're going to click Update, and what we're going to do is we're going to change the capacity provider, and we're going to select the container conf demo as our capacity provider for this service. And I'm going to up the tasks. Let's go with 4 tasks. Okay, so I'm setting the capacity provider to be the one that we just created, that points to the Autoscaling group that we created. And I'm saying I want 4 tasks. I'm going to go from 0 to 4 tasks. So I want this service to spin up 4 instances of the service, and which is 4 tasks. So let's hit Update, and it's done. Successful. Now, here's what we're going to see when we look at the service. We're going to see that if we go back, we can see in our cluster, from the cluster level, I have 4 tasks that are EC2 tests that are pending. And if you look here, I can see for this EC2 service, I have 4 desired tasks, 0 running. Let's drill down and look at what's going on. What we can see is the 4 tasks are in a provisioning state. What that means is because they're assigned to a capacity provider, which is EC2 backed, the tasks are waiting for the capacity to come up and be available so they can be scheduled onto those EC2 instances. So until the EC2 instances come up, it's going to remain in a provisioning state. So we can look here, there's no EC2 instances yet, but what's going to happen in the very near future is basically behind the scenes, the capacity provider is going to essentially trigger an alarm. And that alarm that gets triggered is going to say, basically, we have a target utilization of 100%, but we don't have any instances to support the tasks that are running. So it's going to spin up the EC2 instances to meet the demand. So we'll see that in just a couple moments here. So you can see right now I don't have any instances up yet, but they will be up shortly. So in the meantime, let's update our Fargate service as well. So I'm going to update this service, and what I want to do is I actually want to split this across two providers. I'm going to split across Fargate and Fargate Spot. And what I'm going to do is I'm going to say that I want a base of 1, and I'm going to give, I want a base of 1 for Fargate, and for Fargate Spot, you can only set one base when you split between providers. And I'm going to set, for Fargate, we're going to do a weight of 4, a weight of 1, let's see, and then for Fargate Spot, we'll set a weight of 4. So essentially what's going to happen is I'm going to, when this service comes up, and let's spin up 10 instantiations of this service, of the task. So we want 10 tasks running in this service. So the first one will spin up with the base. It'll meet the base requirement as Fargate. Then the next one will meet the weight of Fargate of 1. And then the next 4 to deploy will be Fargate Spot. And then it'll go to 1, and then the next 4 would deploy via Fargate Spot. So let's actually see what that looks like, because I really need to stop talking about it, and we just need to see it happen. So let's update the service. Perfect. Okay, so now what's going to happen is we're going to get those services launched. But just in the time that I was updating the Fargate service, what do you see here under our EC2 service? We have 4 tasks that are running, and we have meeting our 4 desired state of tasks. We look at our ECS instances, they're up and running, and sure enough, we're in good shape. So in the time that I updated the Fargate service, our EC2 back service has already scaled up the EC2 instances to meet the demand of the tasks that are running. So let's actually take a quick look at that. So I have a load balancer that's running this service. And as you can see here, it's a little cheating ahead, but I have the Fargate Spot and the Fargate instantiations running. But take a look. So what this does is this is an API that exposes all the tasks in the cluster. This is just something I wrote. I created an API service, and then tells you what particular task you're running, and then what's the capacity provider strategy that task is using. So you can see here, if I keep refreshing, it's going to always use this particular container conf demo capacity provider strategy. So that's pretty awesome that in the time of this demo, we had a service that had 0 instances running, 0 tasks running. It was an EC2 back service, and we had 0 EC2 instances in the Autoscaling Group that were running as well. We created a capacity group. We assigned that Autoscaling Group to that capacity group, enabled managed scaling. And then we took our EC2 back service and we scaled it up to 4. And what happened was, in the time that we went away to update another service, and when we came back, we had 2 EC2 instances that were spun up, that were added to the cluster, and those 4 tasks that we were running were scheduled on those 2 EC2 instances using that capacity provider strategy. So pretty cool. Now let's go to our other load balance service, which is again running Fargate and Fargate Spot. And if we count here, if I just refresh, you can see right now I'm running on a Fargate Spot task, but if I keep refreshing, eventually I'm going to hit a Fargate task. So now I'm running on a Fargate task. But so if you remember our strategy, it was 1 base of Fargate, and then with a weight of 1 for Fargate tasks, and then for every 1 Fargate task that's deployed after the base, we want 4 Spot tasks. So we have our 1 Fargate, and then our base of 1, and then our weight of 1, and then 1, 2, 3, 4 Fargate Spot, and then again we have 1 Fargate, and then 3 Fargate spot because we have 10 in the cluster, or 10 services that we deployed. So that's why we have that kind of odd numbering. So that's the demo. And basically what we did in real time was we added capacity providers to our services. We got to see a Fargate service that took advantage of Fargate and Fargate Spot. So we got to take advantage of the Fargate Spot pricing. And basically we kind of over provisioned our Fargate service because it didn't need that many spot. But we have them there because from a cost perspective, it's pretty darn good. And then we created we updated an EC2 back service, ECS service, that wasn't running anything at the time, that was pointing to an autoscaling group behind a capacity provider that we created. And what we saw was as we scaled the service up, the demand was there for 4 tasks that couldn't be scheduled on the EC2 instances, and the capacity provider scaled out to meet the demand in real time. I mean, that was pretty quick. So that's it for the demo. And let's go back to the slideshow. And let's talk about kind of the remainder of what we have. So to get started on ECS and with capacity providers, I've provided some links here to the documentation, as well as a link to ecsworkshop.com. So we're constantly adding to ECS Workshop to as new features come out. We're adding those to the workshop to give you hands-on experience with those new features as they're released. So I definitely recommend checking out the ECS Workshop, especially if you want to do the exact demo that I did in real time in the real world. You can deploy this with the ECS Workshop. And we also have a demo of deploying a 3-tier polyglot microservices application. We have a demo of a stateful service, web service using EFS, and more. So keep an eye on ECS Workshop if you want to get some hands-on experience in a workshop type environment that walks you through how to build and deploy. And that's it. So I want to thank you so much for joining us here today. And we're going to open it up for some Q&A. So if there's any questions, we'd be glad to answer them. And please feel free to follow me at RealAdamJKeller on Twitter. Thank you so much.